something that I don't know if you guys do in Algebra 1. I think I do it with my kids in Algebra 2. I can't even remember now. I do it with my kids in Algebra 2. I don't know if everybody does, so I don't know if this is does direct variation, inverse variation sound familiar to you? No. Okay. So direct variation is when two variables vary from each other with some sort of linear relationship. So the format for that is y equals kx. Most specifically, though, it's when they vary in a linear fashion with the y-intercept of 0. So it has to be plus 0. If it's plus another number, it's a linear relationship, but it's not direct variation. So it has to go through the origin, meaning if there's 0 of one thing, there has to be 0 of another. So that's direct variation. Remember that formula, y equals kx. Inverse variation are when two variables vary with each other in a rational type relationship. And there is no y-intercept here, so that's just y equals k over x is the format. And joint variation is when you've got more than two variables. So this particular version of joint variation has y varying directly with x and z. But you could also say that y varies directly with x, yet inversely with z. So it's when a variable is varying with more than one other variable. Sometimes they might be varying both directly, both indirect or inversely, or some sort of combination of both. Okay? I think you're going to find these pretty easy because once you know your direct variation format, just kx, and your inverse variation format, just k over x, the problems are going to use that exact language, directly or inversely. So in this first one, the number of gallons of water, W, used when taking a shower varies directly as the time t in minutes. So maybe I didn't mention this above. When I read this one, the y, is varying directly as x. The y here is varying, there's the word is, being an equal sign, is varying inversely with x. So here, the number of gallons of water used when taking a shower, that's like your y, W, is varying directly, so that's k times your time in minutes. Then they'll give you something here, like a circumstance, because k is called, and I'll write this at the top, k is called the constant of variation. It's like the rate of the variation. So they give us a circumstance that is going to allow us to find k right here. A shower that lasts 5 minutes, so t is 5, uses 30 gallons of water, so W is 30. This is essentially going to give us the rate of the shower. So divide both sides by 5, and K equals, essentially that's 6 gallons per minute. And then once we know what the K is for the problem, we kind of go back up and we know the equation that we can now use no matter what they ask us. So now they're actually going to ask us a question. How much water is used in a shower lasting 11 minutes? So that would just be 66 gallons. What else comes to mind when you read a question like that? What other math strategies, math vocab words, if anything? When you read a type of problem like that? Because I think a lot of you could have gotten that answer without me teaching a thing here. Anybody? Okay, then never mind. I won't address it. On the second one, the distance required to stop a car varies directly as, so the distance, d, varies directly as the square of its speed. So now you got to be careful of little words like this. It's not varying directly as the speed. It's not just an s there. It's varying directly as the square of the speed, so that would be s squared. What I also find at this point in my career, when I get to this day, is that a lot of people confuse square root with square. Okay, it's not square root, it's the square that's actually squaring something. So, there's our format. Again, they're going to give us a circumstance, a given scenario that's going to allow us to find the constant k. So if 200 feet are required to stop a car traveling 60 miles per hour, stop there and find k. Don't even worry about what question they're asking till we find k. So I'm going to divide both sides by 3,600. How am I supposed to do this without a calculator? There's an answer to that question. Aiden? 2 over 36 is 1/18. Very good. So now I have the formula that I can use for good. So now let's answer the question. How many feet, so they're looking for D, are required to stop a car traveling 100 miles per hour? You should know it's going to be more than 200. It's going to take longer than it did when you were only going 60. So 100 squared is what? No. What'd you say? 10,000. Okay, yeah. I thought you said 1,000. And then, essentially that's 10,000 over 18. Those are both divisible by 2 anyway. So 5,000 divided by 9. And you might hate that, but unfortunately it is what it is. We just have to do a quick long division. 9 goes into 50 5 times. 9 goes into 50 5 times. Do you see what's going to happen here? 9 goes into 50 5 times. And we're pretty much done with numbers, but we have a remainder, right? And if we keep going in decimal form, it's just going to be 555.5 repeating feet. Do you remember when you used to do that with decimal long division? Any questions? Next, the length of a violin string. I'll use L. Varies inversely as. So this is inversely for the first time, so K over. As the frequency of its vibration, so we'll call that F, frequency. They're going to give us our circumstance, a violin string 9 inches long equals K over 650. Solve for K. 650 times 9. So K equals 5850. Now we have our equation. We can answer the question. What is the frequency of a 10-inch string? Marissa, where am I going to plug in the 10? Good. So 10F equals 5850 divided by 10, F equals 585. And frequencies, units are in cycles per second. Any questions? Mitch, were you still looking? Sorry. You good? Everybody good? All right, we're just going to get, I just noticed on the back. Don't worry about that date. This is what I told you. Thursday, 10. Looks like I'm ahead of the game from where I was a few years ago. 10. What's today? So Thursday's the 25th. Oh. All right, so are they good now? Okay, cool. Thank you. All right. Try to, let me see. Oh, no, I'm going to do this one, and then I'll set you free on the next one. The number of minutes needed to solve an exercise set of variation problems. So, number of minutes. What variable do you want to use? What? T. Oh, time, okay. I was going to go for M, minutes, but that's all right. That's better. T for time's better. Varies directly as, so K times the number of problems. What do you want to use for that, Nate? What letter? P for problems, good. And, so this is joint variation. And inversely as, so inversely means over, K over, and the K is already there, the number of people working to solve the problems. Uh-oh, number of people. We can't use P again. P is for problems. Let's do S for students. Sound good? What'd you use? Oh, human. Good. Now that's the equation you're using. I want you guys, number one, find K. Number two, then answer their question on your own. Go ahead. Sarah, what'd you get for K?
8.
Did anybody get anything other than 8? Raise your hand if you got 8. Raise your hand if you weren't there yet. Okay, I'm going to run through that really quickly. 4 people. Oh, that's students. 32 minutes to solve 16 problems. So 16 divided by 4 right away is 4K. So K is 8. Good. And for your answer, Connor, what would you get? 24 minutes. That's 8 people, 24 problems. And those cancel. Good. So, just really quickly, you can, varying directly often means that if this goes up, so will that, right? If the number of problems goes up, so will the time it takes to do them. But kind of working on the contrary to that is the fact that, well, if you add more students to the mix, you got more brains working on it, should be less, should take less time. So those are kind of working in cahoots with each other and kind of battling. Number of problems makes it go longer, but number of students adding on makes it go shorter and kind of gets it all, to work out. All right? All right, try the next 2 on your own, and then we will touch base. Raise your hand if you're done with both. Raise your hand if you're stuck somewhere. Raise your hand if you just need more time. Okay, keep going. Exercise 5. Oh, Mackenzie. What is the volume? On this one?
Yeah.
Have you done this one yet?
No, that took me a while to figure out
The formula, gotcha. What was your formula? We'll start there.
It is y equals v.
Can I do V equals? When they tell you what variable to use, you got to use what they tell you. Okay? So V equals K H R. So yeah, this one's a little bit different because it doesn't say directly or inversely. Like it doesn't kind of stack those words. When they say just straight jointly, it is direct for both. Any issues with that? Andrew? Right, it should be KHR squared because it's jointly as its height and the square of the radius, not just the radius, so R squared. And so when you plug in what you know, Andrew, what did you get for K? Does anybody get anything different? I mean, assuming, from the people who use the right equation, anybody get anything different? Because we'll just assume if you use the wrong equation, then your answer here is wrong. So pi over 3. And then we go find the volume of a cone having a radius of 12 and a height of 2. So when you're simplifying this, I'm going to change that to 144. And 144 does, or better yet, what if I just keep it 12 times 12? And then one of those 12s can reduce with the 3. What's 12 divided by 3? 4. You guys are no fun with participation. And then 4 times 2 is 8. 8 times 12 is 96 pi. Raise your hand if you got that. Okay, just a couple. Abby, what was your mistake?
I put r squared in the denominator.
Oh, gotcha. Okay. Well, you know what? Maybe that's my fault. So if they just say joint variation, it's that all direct. And then I'm just showing you too that like we can mix and match, and they'll use the different terms for that. And then the last one, the distance s that a body falls from rest varies directly as the square of time. That's kt squared. If a skydiver falls 64 feet in 2 seconds, so divide by 4 on both sides, and we get k equals 16. Go back up. How far will they fall in 4.5 seconds? Probably a calculator on this one. I'm not going to make you do a decimal. You could do 45 times 45 and move your decimal place over and multiply. I won't do that to you. Unless the decimals worked out nice, like a 1 point, well, no, like a 0.9 times a 0.9. You should know that, right? Like a 0.81. Yes. But squaring 45. All right, any questions? All right, your homework's there at the bottom. Great review